If half the modulus of the complex number 6 minus 8i is equal to the modulus of 4 plus ki, then find two possible values of k, where k is an element of the real number set. Okay, so when we see these lines in general in maths, they represent distance. And specifically, when we are dealing with a complex number question, which we are because we've got i's involved, these lines represent the modulus, which is actually the distance from the origin. So we want to get half the modulus of this complex number, equal it to the modulus of this complex number, which involves a k, and then solve to get the k on its own, so solve for k. So when we are finding the modulus, we ignore the i's, and we use the formula, the square root a squared plus b squared. So that's our formula, where the a represents the real part and the b represents the imaginary part without the I. So in this complex number here, the 6 is the real part, so the 6 goes into the first bracket, and the minus 8 is the imaginary part. The minus 8 goes into the second bracket. So we've got the square root of 6 squared plus minus 8 squared, because the 6 is the real part and the minus 8 is the imaginary part. Remember, we do not include the I down here. Now there was a half stuck on to the modulus of this complex number, so I'm going to put brackets around my formula, and I'm going to stick a half in front, so it's going to be half multiplied by this. This is equal to the modulus of 4 plus ki. So again, we use our formula, the square root of a squared plus b squared, where the a is the real part and the b is the imaginary part. In this complex number, the real part is 4, so 4 goes into the first bracket, and k is the imaginary part, so k goes into the second bracket. So all we have to do is multiply out the half, work out what's inside the brackets, simplify this as much as we can. We're going to leave it in terms of k initially, and then we're going to solve to get the k in its own. So half stays as it is. 6 squared becomes 36, minus 8 squared becomes 64, positive 64, not minus 64, be careful with that. And we still have our square root. So it's a half multiplied by the square root of 36 plus 64. This is equal to 4 squared gives us 16, k squared gives us k squared, and we leave the square root in front. So now we have this in terms of k. Okay, so now we're just going to work out what's going on over here. And for the moment, all I'm going to do is work out 36 plus 64 to give me 100. So I still have my root. So I have a half multiplied by square root of 100 equals the square root of 16 plus k squared. Nothing changes with this for the moment. So a half stays as it is for the moment. Square root of 100 is 10. And root 16 plus k squared stays as root 16 plus k squared. Okay, so a half of 10 is 5. And this is equal to root 16 plus k squared again. Okay, so now we need to get rid of the square root part before we get rid of the 16 and the squared part. And if we want to get rid of the square root, we basically need to bring it over the other side, and it turns into its opposite, which is squared. So the square root is going to come over the equal sign, and it's going to square the 5, which will give you 25. So the square root came over the equal sign and squared the 5 to give us 25. So this is now equal to 16 plus k squared. Notice that the square root is now gone. That's very important. Okay, so we're nearly there. We almost have k on its own. We need to get rid of the 16, so we're going to minus 16 to the 25. We're basically minusing 16 to both sides. So if we minus 16 from 25, if the 16 comes over here and becomes minus 16, 25 minus 16 gives us 9, and this is equal to k squared. Now all we have to do is square root the 9 to get the k on its own, because the opposite of something squared is square root. So we're going to bring this squared over the equal sign and becomes the square root of 9. So the k is going to be the square root of 9, which is going to be plus or minus 3. So the two possible values of k are plus 3 and minus 3.